Hello everyone, I'm Paul and today we're solving problem 1298, maximum candies you can get from boxes. This one is hard and there's a lot of things going on here, so we'll go from simple to complex. The main idea here is that we're given n boxes and each box contains candies, and we need to return the maximum number of candies that we can get from all the boxes. Some boxes are open and some are closed. We are given an array status, which tells us which ones are open and which ones are closed. We'll use 1 for open and 0 for closed. We are also given an array candies, which will give us the number of candies that we can find in each box. We are also given an array keys, which are keys that we will find inside each box. We can use those keys to open other boxes, and we are also given an array contain boxes, which represents small boxes that we will find inside each big box. Finally, we are given an array initial boxes, which represents the boxes we have initially. So as you can see, there's a lot going on here. We are given 5 arrays. And just to be clear, we are giving boxes. Each box can have a status of 1 or 0. This means it can be open or closed. And each box has candies, keys to other boxes, and other boxes, other small boxes inside this big box. And we need to return the maximum number of candies that we can grab here from these boxes. So let's go with an example and how can we solve this. Let's say we have these boxes. Remember, 1 is for an open box and 0 is for a closed box. We have C, which represents candies in each box, key represents the keys in each box, and CB represents the contained boxes in each box. So for example, if we take this box at index 0, this one is open, it has 7 candies, it has no keys, and it has boxes 1 and 2 inside. So it has this and this inside. And we are also given initial boxes, so in this case, let's say we are only given box 0. Now we will use some sets here. First, one to keep track of open boxes, another one to keep track of the keys that we have, and another one to keep track of the boxes that we have already seen, and the result is initially 0. So the main strategy here is to use BFS, and we will start with the initial boxes, and from each of these we will go to every neighbor, meaning to every contained box. In this case, we go from 0 to 1 and from 0 to 2. Remember that in BFS, we go first to every neighbor. So here we go from 0 to 1 and from 0 to 2. This is level 0, this is level 1. And here, for example, we will go from box 1 to box 3. So from box 1 to box 3, this would be level 2. But this is only if we can open this box, because it's currently closed. So now we run like a simulation here, and this will be naturally a BFS. You will see why. We start with the initial boxes, and we have box 0 here only, so we add to scene box 0. And this box is open. This means we can grab all of this. So we add to open box 0. We don't have any keys here. We add 7 candies to the result. So this is now 7. And in here we have 2 boxes, 1 and 2. So now we will iterate these boxes. So we add to scene box 1 and box 2. First we go with box 1, it's closed, and we don't have the key for box 1, so we continue with box 2. Now box 2 is already open, so we can grab all of this. So we add to open box 2, we add to the result a 4, so this is now 11, and we add to have keys the key for box 1, so here we have a 1. And now it comes the tricky part for this problem, and I think this is why this one is hard. We have the key for box 1, but we have already seen box 1. So here we will have like a special case in which if we have already seen a box, we have the key for that box, we will open it. This means we will add the box to the queue again. So right now we have already seen box 1 and we have the key for box 1, and box 1 is not in open. So we add box 1 to the queue. Now we have this in the queue and this is 0, but we have the key here, so this is now open and we can grab all of this. So the result is now 16. We have no keys here and we have box 3 in contained boxes. So now we have box 1 opened, and from box 1 we are going to box 3. So we add 3 to scene and we're checking if this is open or closed. It's closed and we don't have the key, so we can't grab this, and now our queue is empty, so we return the result, which is 16. Overall time and space complexity for this one will be big O of n, meaning the amount of boxes, plus keys, meaning all the keys that we can have, plus CV, meaning all the contained boxes that we can have. We are basically storing all of this in different sets and we are iterating through all of these things. So now let's go with the code and hopefully you will get the idea. First, the result is 0, open is a set, have keys is another set, scene is another set, and here we'll add initial boxes. We will have a queue and we will use a deck. Remember that this is to pop elements from left, which is what we need for BFS, and we will start with initial boxes. And now, while we have something in the queue, the current box is queue.popLeft, and now we are checking if we need to continue, meaning if the status of the current box is 0 and we don't have the key from the current box, or if we have already opened the current box, we continue. So if status box is 0 and not box in have keys, or box in opened, continue. Now if we can open this box, we open the box and we grab the candies, grab the keys, grab the contained boxes. So now we open the box, opened dot add box, result plus equal candies add box for every key in keys box have keys. We add the current key to have keys, and this is the tricky part. If we have already seen the box corresponding to this key and we don't have the box corresponding to this key in opened, we want to add this box to the queue again. to check in the future if we find the key and we can open this box. This is the most tricky part of this problem. So if x in seen and not x in opened, q dot append x. And now we grab the contain boxes. So for cv in contain boxes at box, if not cv in seen dot add cv, and q dot append cv. And finally we return the result. So this is it for the code, and now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.